State trees are an awesome tool, new to Unreal Engine, but through using them in my own projects, I found that there's a lot of depth to them and not a lot of information on them yet. So I wanted to make a tutorial that simplifies them as much as I can. And I've come up with 3 things that I think need to be understood to start using state trees. But before we dive into those 3 things, I want you to think about something. When does learning actually happen? I've tried learning by following the steps of a tutorial, and as soon as that video is over, I just forget everything that I just heard. So instead, I've started learning by doing. The act of just diving in, reading the documentation, trying and failing until I get something that works helps me learn and understand how stuff works in this whole game design process. So for this tutorial, I've included the project files down in the description, and I welcome you, I challenge you to just start by downloading those files, reading through them, and trying to figure out what's going on and how state trees are being used in that project. Now, if you decide to do that, please keep this video playing in the background because I need the watch time. But if you don't learn the way that I do, the rest of this video is for you, so let's get into it. Now, Epic defines state trees as general purpose hierarchical state machines that combine selectors from behavior trees with states and transitions from state machines. So the state tree is basically just combining the best of both worlds. It gives you a way to create highly performant logic that stays flexible and organized. I do want to mention that state trees aren't just used for enemy AI. You can use them pretty much everywhere you can see their functionality being useful. In my last project, I managed to transition between levels and have a wave spawner that ran on a state tree. I also want to mention that state trees are still buggy. Maybe even during this tutorial, the project might crash. So use at your own risk, save early, save often. So first we got to start by defining what we're actually making in this tutorial. My goal here is to make an enemy that patrols between points in a specific order on the map. So I need to understand the states that this enemy will have. So I'm just going to go ahead and draw that out. We have our patrol enemy. And when I think of this enemy, he's going to start at one location, walk to another, and then wait for 1 second, walk to another, wait for 1 second, and then return back up here and wait for 1 second. So the states that we have are really just idle and move, and we will just cycle through these points. So let's keep it simple for this tutorial. That's all we're making. So let's start getting our project set up. I'm using Unreal Engine 5.2. I'm going to try using this magnifying tool. If you love it, let me know. If you hate it, let me know. We're going to come into games, and we need a new third-person blueprint. I'm just going to name this State Tree Example, and we'll create the project. All right, so now that we have our project, the first thing we need to do is enable state machines. So we will come up to edit plugins, and we need to search for state tree, and you'll have 2 options: gameplay state tree and the state tree. We need both, and the engine is going to have you restart for these changes to take effect. Go ahead and restart. So specifically, enabling those 2 plugins gives us the ability to create state trees. So if you come into your content browser, just right click anywhere. We're not actually making anything. I'm just showing you what those changes did. If we go to artificial intelligence, you'll see that we now have artificial intelligence. We now have the option to make a state tree, but we're not going to do that yet. We still have some more parts of this project that we need to set up. Like I said, we want to have an enemy that walks around set patrol points. So we need to make those patrol points. Now, there is a lot of ways to do this. I'm just going to do my favorite way. Feel free to follow along, or just do it your own way. Let me explain what I'm going to do here. I am going to create an object that will be called a path marker. And then I'm going to create an actor component that can contain path markers. And we can just attach that to the character. I like it because it allows me to move the points around in the world and not mess with them too much. So I'm going to make a folder. I don't want to make a folder here. I'm going to make a new folder under content. And we're going to call this enemy. Within our enemy folder, first thing I'm going to create is a blueprint class. And this blueprint class is just going to be an actor, and we'll call this path marker. We'll open path marker. And the only purpose of the marker is to just be a visual representation of a location. So over in this top left corner under components, we'll hit add. We'll add a cube, and I'm going to adjust the dimensions. Whoops, accidentally renamed the cube. Nothing. Let's call this cube. I'm going to adjust the dimensions of this. So it's just small, portable, easily spotted within the map, right? And we're going to save that. We're going to come back to the content drawer. And next, we're going to create a new blueprint class. This one, you'll want to hit actor component. And we'll name this troll path. I guess the proper naming convention would be like AC underscore patrol path. So we know it's an actor component. Open up actor component. And all this needs to hold is a list of path markers. So over under the variables window, make sure we can see this. Over under the variables menu, hit variable, and just let's name this patrol path. And it is going to be of type path marker, because that's what we named our actors. And we will hit compile. And then the last thing we need to do is turn this into an array, because we want it to represent multiple of those. And save and compile. Now we got our pathway marker. We need something to actually attach these pathways to. So let's go ahead and create an enemy character. To keep this simple, we're just gonna use what's already in the default engine. The content drawer, in our enemy folder, right click, blueprint class, and let's create a character, and we'll call this BP underscore troll char. Go ahead and open that up. And since it's a character, it inherits the ability to move. So we already have a mesh baked in. I'm just going to set this mesh. Select this mesh in the left panel, and on the right panel, I am going to select SK Quinn, SKM Quinn, and let's bring her down to the floor and rotate her 90 degrees so she's facing forward. Next, since she's going to be navigating through a patrol path, she needs to have a patrol component. So if we come into the add menu and search patrol path, that custom component that we created should be selectable. And we can compile, save, and for now, that's all we're going to do to this character. Now let's actually set up our patrol path in the default level. So in order for an AI to move, I do it using a nav mesh. So over on the left side of the screen, I'm going to hit place actor. And then I'm going to search for nav, and we want nav mesh bounds volume. We can just drag that out, place that in the world. And let's make it bigger. Bigger and taller. I'm going to have our actor just patrol around this gray object that we have in the middle of the map and walk up this ramp and walk back down. That seems like fun. So to verify that this is walkable, while this is selected, you can just hit P. And if it's green, it's walkable. Navigable is it navigable a word? It's walkable if it's green. So next we need to actually place our patrol points. So I'm going to grab a path marker and drag it into the world. I misdragged. Try that again. Drag that into the world, and I'm gonna put these at the points where I want our character to walk to and pause. Keyboard shortcut is Control D for creating duplicates. Just gonna hit these four corners. And then our final patrol point will be up at the top of this ramp. We'll just have her come walk over to here. And so now we can drop our actor into this level. And I'm sure you're probably thinking we have to be able to put these in an order. So with our enemy actor selected, this is the enemy actor, right? Check the outliner. Yeah, that's our patrol character. With our patrol character selected, we can enter the details panel, and you'll see under the patrol path component we've added. Oh, I forgot. I made a mistake. We got to open up our patrol path blueprint again. So come into the content drawer, open AC patrol path, and this pathway marker needs to be instance editable. And I think exposed on spawn may not matter. I'm going to enable it anyways. So with those enabled, recompile the blueprint. And now, with our character selected, if we look in this panel under AC patrol path, you'll see we have patrol path. Patroth? Man, I spelled that wrong. We can add elements to this array. So I'm going to add 5 elements to the array. And we'll use this little dropper tool and select the path markers. And you'll see that that path marker has now been set. So I'm going to repeat that process for all 5 of our patrol paths. Now the order that they are in this array is the order that our patrolling character will walk through them. Now, with that completed, our next step is to create the state tree. We've completed project setup. Now we got to create the state tree. This is where we'll get a little bit more interesting. So in the content drawer, in our enemy folder, I'm gonna right click, gonna hit artificial intelligence, and we're gonna create a state tree. You only have one option, state tree component. Create that, and I'm going to name this st underscore control char. And now state trees are components, so we have to attach the state tree to the character that we want to run the state tree. So I'm going to open up our patrol character again, and under the components tab on the left side of the screen, hit add. Go ahead and search for state tree and add the state tree component, hit compile. Now you'll notice on the right side of the screen, with state tree selected, on the right side of the screen, we now have some options. We need to set the state tree to the one that we want to use, you should only have one option, one I just created. And that should be that's all the setup that's needed for the state tree. So let's open up our state tree. When you open up the state tree, you'll notice there's kind of these three main panels. First one is the state tree panel. It gives you some details about parameters, things that your state tree has access to use throughout the state tree. The middle panel is where we actually define the state tree itself. By default, it comes with a root. And the right side is the details panel. As you select items from the state tree, the details panel will populate and you'll be able to edit some of those. But let's focus on this state tree. Well, you might also notice that there's this state tree statistics panel. I don't know what it does. If somebody out there does know what it does, I haven't been able to glean any like valuable information from it yet. But please let us know in the comments. So the three things we need to understand to use state trees well are context, task, and transitions. Context is basically defining some information that the state tree can access and use and change. They're similar to Blackboard keys. If you've ever used a behavior tree, they just require way less effort to set up. All we have to do is set our context actor class to our VP underscore patrolling character. And that gives us access to every variable that our patrolling character has wherever we want to within the state tree. You'll also notice that the context has updated to be BP patrol character. Be cautious. This is one of those areas where you can get some bugs if you try to change this while you're using the state tree. Sometimes it sticks, sometimes it doesn't. But we should also, this tutorial isn't really going to go into parameters, evaluators, and global tasks, but I just want to mention them just so you know that they exist. You can think of a parameter as a variable that you set once and it's read only, right? So if there's a variable that we want to access multiple times in a state tree, we can create a parameter and use that variable multiple times within the state tree. That way, instead of having to jump around and change it all the time, we can just update that one parameter. I think I can come up with an example on the fly. Well, let me give you an accurate description of evaluators. All right, so right now we're looking at the state tree documentation on Epic Games' website. I'm just gonna hit the state tree overview, and it should give us a brief definition of evaluators, right? Evaluators provide a way to expose data to the state tree that would otherwise not be possible to do so with parameters or context data. Evaluators are a separate class that can be executed in a state tree during runtime. Evaluators contain variables and can execute custom code when the state tree starts, stops, and on each tick. The properties of an evaluator can be bound to parameters or context data or other evaluators that come before it in the evaluator list. So it's a way to manipulate data that you wouldn't be able to manipulate with a parameter. And a global task is a way to run a state tree task that can become active between start and stop events of the state tree. So I've seen these used as like ways to set up data that you would use between runs of the state tree. I haven't used them yet, so I'm not going to go into them too much. But back to it. So now that we have our context set, let's go ahead and create a couple of states. So by default, you get the root state. First thing we'll do is add a state. This first state will be idle. And I'm going to add one more state. That second state will be move to location. Those are the two states we discussed adding beginning of the video, so we'll just keep those what they are. Now, I do want to talk about states a little bit. States aren't actually doing the work. Tasks do the work in a state tree. A state contains a task, right? Now, there's different types of states, as you'll see in the details panel. If we click this drop down, you could have a grouped state, which is just a state that contains a bunch of substates. So if move to location had a state where first it got a location and then it rotated to face that location and then it moved to that location, that could be three separate states defined within the same state. Um, they can also be subbed trees or linked trees. I haven't used those yet, so we're not going to dive into those. Put those on the back burner. States also have interconditions. So if you want to prevent a state from being entered into unless a specific variable is set, here we'll go ahead and look at the we're not going to use these in this tutorial, but I think it's good to have a cursory knowledge of it. So if you hit the plus sign, you'll see this drop down menu where you can add some elements. You can set conditions based off booleans, distance, enums, floats, integers, or just a random condition. I guess a good example of this would be you don't want to enter into a chase state unless the patrolling actor has seen the character. So you could have a condition that says if is chasing, enter this state, or if player character is seen, enter this state. I'm going to go ahead and delete those. The next thing here is task. So for this idle state that we're looking at right now, all we're doing is waiting. One of the nice things about state trees is you do have a delay task built in. If you hit this drop down, you'll see delay task that populates this item right here as another drop down. So you get a duration, a random deviation, or run forever. You'll also notice that every variable has the option to be bound to something. So this is a good opportunity to use a parameter. If we come back to the left side of the screen, we can create a parameter, and let's rename it to default delay. And then let's change this to a float type. And let's just have our default delay be 1 second, 1.0. Now, if we need to access this delay variable at multiple places within our state tree, we can now just come over to our delay task, and under duration, let's go over to bind parameters, and then we can just bind it to this default delay. So that just makes it a lot easier to, if you want that delay to be consistent, but you're using it in multiple state trees or in multiple places in the state tree, you can just update it in one place. I think that's pretty easy usage. I think we should also mention that state trees do have some limited debugging functionality. This debug task here will just put some text on the screen. We'll make this say I'm waiting. It's just a way to communicate where in the state tree we are. I like to make these a color that I'll notice on the screen. Now we can start. Oh, whoops. I accidentally overrode my delay, so let me re-add this delay in here. All right, so now we can talk about task a little bit more. So as you can see, each state can contain multiple tasks. One thing you need to understand is that whichever task finishes first will drive the transition to the next state. So it is possible to start up multiple tasks. I can't think of a good example of when you'd want to do that, but just know that it's possible. Hey, if you got an example where you'd want to do that, let us know in the comments. I do appreciate learning from y'all. So before we dive into well, I also should mention that this debug this debug text task, when that finishes, it's not going to trigger a transition. This will wait and hit the transition, right? So next we should dive into the transitions because the transitions are how you move around the state tree. So we hit this plus button. You'll notice by default, the transition is dependent on when the state completes. So we have a list of triggers here, 5 triggers. There's completed, succeeded, failed, tick, and event. Um, I don't know why you would want to trigger a transition on a tick, so I'm just not going to touch that one. Succeeded and failed are pretty self-explanatory in my opinion. Or if they're not clear now, they'll become clear a little bit later. An event is a pretty useful transition that can be triggered from outside of the state tree. Um, if you're interested in a tutorial on event, I'd be happy to make one. Just let me know. But for this tutorial, we'll just be using completed and succeeded. So we'll say after the idle has completed, we need to tell it where to transition to, and we want to move to location. And as always, we can make these dependent on conditions. So let's say you have a state that's running 2 tasks. You would have you might have 2 potential transitions. You can use conditions to manage which transition you'd like the state tree to take. So now let's look at our state tree itself. You'll notice a lot of symbols on the state tree. If you learn how to read those symbols, it becomes easier to gather a lot of information at a glance. So when we select a state, the orange side is the state itself, and the blue side are the tasks that are running the state. I'm not sure what the paper plane means, but this arrow tells you the next state that it tells you the states that it transitions to, right? So in move to location, we need to add a task. But as you already saw, movement is not covered by default in the tasks that are offered. So we have to create a state tree task now. So in our content drawer, go ahead and right click and create a blueprint class. You want to expand the all classes section, and you'll want to search for state tree. You'll see a bunch of options. It's a blueprint base, a condition blueprint base, an evaluator, and a task blueprint base. We're going to be using the task blueprint base. And let's name this STT for state tree task, move to. And we can go ahead and open up the task. I think it's important to understand that tasks operate a little bit different from like the blueprint in your character class. It does have an event graph, it does have functions, but functions seem to drive state trees. So you'll notice that there's 4 functions that you can override. There's an enter state, an exit state, a state completed, and a tick. And they all do exactly what you think. First, we hit the enter state. After the state is entered, we'll hit tick, and then we'll hit the exit state. And if we return a state completed, we'll hit state completed. So let's start by checking out what's in interstate. So you notice that there's a return node here. These return nodes are how you leave the state tree. If you expand the enum, you'll see your options are running, failed, succeeded, or unset, right? By default, they'll be set to running. Even if we look at the tick, it's set to running. So what do we need to do to make our actor move? First thing we need is a location for our actor to move to. So let's start by creating that. Let's go back to our our patrol character blueprint. And I'm going to do this through a function. You could do this through an event if you wanted to. I'm going to call this function get next location. In order for this to work, we need a couple of variables. We need a variable called next location. That will be vector. And we need a variable called index. That will be an integer. So we have all of our locations stored in our actor component patrol path. So first thing we need to do is get a location. So if you hold control and grab something in one of these panels, it automatically grabs the getter. So now we have the getter, we need to get the patrol path, the path roll path. And then from that patrol path, we need to get a copy of a patrol point. That's where index comes in. We have to define the index. So I'm going to hold control, grab index, plug that in right there. And based off of what we get, we need to get the actor location. Get the actor location of the point that we grabbed from the array. And we need to set, if we hold Alt and grab next location, that'll set next location. Now we need to cycle through our array. So we need a condition. Branch. Let me spell branch too. Can't spell today. And this branch is dependent on the value of index. So there's only 5 items in our array. Well, so when we get to the end of the array that we have, we need to reset the index back to 0 and go back to the first patrol point. So off of patrol path, we'll get length. I believe length is just the number of items. So I believe we want length -1, right? There's 5 items in the array. This might be a bug, but we're going to try it out. So if index is greater than or equal to the length of the array, we want to reset index back to 1, hold Alt, grab index, reset it back to 0. But if it's not, we can just increment index. So that is how we will go about getting the actor locations. Let's take a moment to save everything. And we'll come back to our state tree. And now if we click move to location, we should see that we have the option under the task menu to select STT move to. We'll select that, and now we need a way to access, because our actor has the next location as a variable within it, we need to be able to access that variable. That's where context comes into play. So in st move to, we're going to create a variable. We'll call this self reference, and we will make this of type BP patrol character. And we need this to be exposed on spawn, or we need it to be instance editable. And that way, when we come back to our state tree, hit compile, you should now see that you have the option to set the variable that we're bringing into it. And again, we can just bind this to actor since actor is set to BP patrol character, it will just reference our patrol character by default, which I think is pretty handy. So now we need to look at when we enter the state. Let's look at that function. The first thing we need to do is set our next location. So I'm going to grab our self reference and I'm going to call the function that we created, get next location. And now we need a way to actually move to the location. For this, there's a bunch of different ways to do this. You could do this off the tick. You could do this in the event graph. I'm just choosing to use the event graph because I can use the AI move to node. So in our event graph, we're going to create a new custom event. We'll just call this move, and we will call AI move to. The reason why I like AI move to is because it's a latent action, meaning that execution halts until it returns a result, and it gives us a very clear success or fail. So for our pawn, we need to get our self reference, drag that into pawn, and then it needs to know the destination to move to. So off of self reference, we'll say get next location variable. Drag that in there. And then we have this acceptance radius. It's how close do we need to get to the location, to get to the destination, for it to be good. I usually set that to like 25 or 30. And you'll also notice that there's this target actor. If you wanted to use AI move to a specific actor, you could set that up, right? The next thing we have is this on success or on fail. So how I'm going to use this is we have to tell the state tree when we're finished moving. And I'm going to use these execution pins, these output pins, to set the enum that we use to exit this task in the state tree. I'm going to come over to tick. I'm going to right click on return value. I'm going to hit promote to variable. We're just going to name this. What should we name this? We'll name this movement result. Right? And so whatever the value of movement result is will be constantly returned through this tick. By default, it should be set to running. We have a bug there, but I think it's going to go away. I think it's just because I haven't compiled. Yeah, I didn't compile patrol character. That should resolve that bug. Yeah, so that's happy now. Okay, so back to what I was saying. I'm going to set movement result based on these execution pins. So if we successfully made it to our location, we'll return succeeded. If we didn't make it to our location, we'll set this to failed. And then once these two things are set, our task will know to exit based off of the value that's being read in this tick function. Now you might be thinking, why can't we just use the return node in the event graph? You don't have access to the return node within the event graph, so kind of have to come up with a creative solution there. Like I said, I'm sure there's plenty of ways to do this. This is just the way that I'm doing it. Now, I do want to go back to interstate because I spent like 30 minutes. I did a dry run of this, trying to make sure I knew what I was doing, knew what I was talking about, and I actually forgot to create. I forgot to call the move function. I spent like almost 45 minutes trying to debug that. So make sure you come back in to interstate and call the move event that we just created, right? And so now we can look at our state tree again. You'll notice that the state tree is giving you a warning because we haven't defined a transition after we finish move to. So come in here and let's change on state completed to succeeded. And if it succeeded, we want to transition back into idle. One of the things about state trees is after you've started, you don't have to go back to the root. I don't know how useful that is, but it's cool. You never have to return back to the root, right? But you'll notice that even after we've set on state succeeded, it says we're still missing a transition. And that's because you can either succeed or fail. So if I'm right, if we add a on state failed, that should go away. And if it fails, we'll just keep moving to the next location just because we can. And so if we look at these symbols again on the state tree, this green check mark means succeeded, move to idle. This red one means failed, move to location. So we no longer have a missing transition notification either. And with that, we are almost done here. There's one more thing that we have to change to make our actor look like they're actually walking. So if we come into our character and select our character mesh, and then we navigate to our oh, well, I guess I forgot this too. Okay. Since we created this character, we have to assign an animation blueprint. We can just use the default Quinn blueprint. We will just have to change one thing in there. So now we can open up the Quinn blueprint, and the Quinn blueprint works by calling the Manny blueprint. So we should actually just open the ABP Manny blueprint. And this should move variable determines whether the walking animation will play or not. And it is tied to the acceleration of the movement component. And I believe if there's no input being applied to the input vector of the animation blueprint, it'll just never get set. Because by using the AI move to component, it or by using the AI move to node, it does change the ground speed of the actor, but it doesn't actually apply input to the input vector. So I'm just going to make this dependent on if the ground speed is actually set. And that should allow us to look like we're moving. Now we can hit play. And let's see if everything works. So her movement speed is 600, so she's going, she's running. She hits each patrol path. She should go up the ramp now, stands there, and then she should return back to the first one. And she will just keep doing that indefinitely. All right, so cool. All right, so with that, we have a patrolling character that functions solely on state trees. Just to sum it all up, the important things to remember here are how context works, how task works, and how transition works. Like I said at the beginning of the video, really the only way to get good at these things is to just start playing with them. So go out there and make something cool. If you have anything to add in the comments, if I missed anything, please let me know. Like I said, there is a lot of depth to state trees. You can start getting into EQS stuff and doing really cool things with those. I haven't done any of that stuff yet, so I won't be making a tutorial about that. But I hope this helped you. Peace. I just realized there's a bug, and the bug is exactly where I thought it was. So, um, if index, we really just want to get index. If index is greater than or equal to array length -1, that's what should drive this transition. And that should fix our bug. Let me make sure everything still works. Can't be putting out buggy tutorials. All right, do we still hit the 5th point? We do still hit the 5th point. Go back to the 1st point. And let's make sure there's no error messages. Okay, that's it. Peace, guys.